Section 14.2, limits and continuity in higher dimensions. So just to think about where are we in our tour of calculus of functions of more than one variable. So last section, section 14.1, we said here's what a function of 2 or 3 variables is. Next section, we'll want to be doing derivatives of functions of 2 and 3 variables. Well, before we get to derivatives, think back to calculus 1, we have to talk about limits. Okay, so limits and continuity in higher dimensions. This is just going to be a little intro video. We'll do a lot more later on here. There is a technical definition here that you can see in the textbook. We say the function f of xy approaches the limit L as xy approaches x naught y naught. Limit xy goes to x naught y naught to point in the plane. F of xy is equal to L. And now we have an epsilon delta definition here. If for every epsilon greater than 0, there is delta greater than 0, such that for all xy in the domain of f, note here that this is the absolute value of f of xy minus L is less than epsilon whenever this is the distance from, distance formula here. This is the distance from xy to x naught, y naught needs to be less than epsilon. So the idea is that, let me come back here to draw a picture. We want to think about, here is our point x naught, y naught. The idea is that our function, we are picking points that are going to be closer and closer and closer to, like this is an xy, this is an xy, so on and so forth. We're picking points xy that are getting closer and closer to x naught, y naught, and we want f of xy to be getting closer and closer to some number L here as we are getting close to x naught, y naught. By getting closer and closer, I should be saying, to make this more precise, we can make f of xy arbitrarily close to L as we get close to x naught, y naught. And so that's what's going, this is the basic idea here that we have to talk about. It's the idea of limits in, calculus 1, way back in, was probably chapter 2 for you, all going down into, now we're bumping up to functions of 2 variables. And so there are some basic rules that we can have here. Next video, we'll see some more basic rules. For example, the limit x comma y goes to x naught, y naught of x is just equal to x naught. We can just do this by substitution. The limit as xy goes to x naught, y naught of y is going to be y naught. The limit as xy goes to x naught, y naught of a constant k is just going to be k. So a lot of this stuff is going to feel the same, but the thing that's going to be tricky, and we'll be spending a lot of the rest of the video talking about this, is in functions of one variable, if I want to think about the limit as x goes to 2 of some function f of x, there's only 2 ways to go there. We can go from the right, or we can go to the left. This is the limit as x goes to 2 from the right, or this is the limit as x goes to 2 from the left. But now there are many ways to go. We can go like this, go like this, go like this. We can go like that. We can spiral in. There are many, many, many ways to approach. And so we have to be careful. Lots more discussion to come.